Have you ever wondered if you could hop into a machine, travel back in time, and change the past, or zip into the future to see what it holds? Welcome to the intriguing world of time travel, a concept that has captivated human imagination for centuries. Imagine being able to revisit historical events or fast forward to unravel the mysteries of the future. The allure of time travel has been an irresistible force, pulling us into a vortex of endless possibilities and what-ifs. The idea of time travel has been a popular theme in science fiction, and its roots run deep. It was H.G. Wells, the father of science fiction, who first introduced us to the concept in his groundbreaking novel, The Time Machine. Since then, it's been a focal point in countless books, movies, and TV shows. Who can forget the iconic DeLorean car in the Back to the Future series, which allowed Marty McFly to journey through different time periods? But time travel isn't just limited to the realm of fiction. It's a topic that's been seriously considered and debated within the scientific community. Theoretical physicists, armed with their equations and chalkboards, have been trying to crack the code of time travel, exploring the nature of time and space in ways we never thought possible. Is there a way to bend the fabric of space-time, creating a wormhole that could serve as a bridge to another era? Could the discovery of negative mass, a theoretical type of matter that defies our understanding of physics, be the key to unlocking the secrets of time travel? These are the questions that scientists are grappling with, pushing the boundaries of our knowledge and understanding. Time travel continues to capture our imagination, sparking debates and discussions around dinner tables and in classrooms. It's a concept that's deeply ingrained in our culture and consciousness. It challenges our perceptions of reality and makes us question the very nature of time itself. But the question remains, is it possible? Can we really break free from the chains of the present and voyage into the past or the future? As we dive deeper into this fascinating topic, let's keep an open mind and remember that in the realm of science, nothing is ever truly impossible. Time travel continues to capture our imagination, but the question remains, is it possible? While there isn't any scientific evidence proving that time travel is possible, recent scientific discoveries have given us a new understanding of time and space. Let's begin by diving into the concept of wormholes. In the realm of physics, wormholes are theorized as mysterious tunnels connecting two vastly different points in space-time. Think of them as shortcuts, allowing us to bypass the conventional constraints of distance and time. Picture a piece of paper, for instance. If you were to mark 2 points on it, the quickest way to connect them wouldn't be a straight line, but by folding the paper so the points touch. That's the idea behind a wormhole, a fold in the fabric of space-time. But how can we create these shortcuts? That's where the concept of negative mass comes in. Negative mass is a type of matter that's predicted to behave in ways contrary to everything we know about physics. It's hypothesized to repel rather than attract other masses, and when pushed, it accelerates towards the force, not away from it. It's like a car that speeds up when you hit the brakes and slows down when you step on the gas. It's counterintuitive, but that's the beauty of theoretical physics. It continually challenges our understanding of the universe. Now, imagine if we could harness this negative mass to create wormholes. Theoretically, negative mass could stabilize a wormhole, keeping it from collapsing under its own gravity. This could, in theory, allow for the passage of information, energy, and perhaps even physical entities from one end of the wormhole to the other. This means that not only could we potentially travel through space at speeds faster than light, but we could also possibly travel through time. However, it's necessary to remember that these are all theoretical concepts. Despite the fascinating possibilities they present, there is currently no empirical evidence supporting the existence of wormholes or negative mass. These ideas are largely the product of mathematical models and equations, not tangible, observable phenomena. Moreover, even if it were possible to create wormholes using negative mass, we would still face the monumental task of harnessing, controlling, and navigating these phenomena without causing catastrophic events. It's like trying to navigate a ship through a stormy sea, not knowing where you'll end up or what you'll encounter along the way. So, where does this leave us? Well, while we can't pack our bags for a journey through time just yet, these scientific concepts do give us a tantalizing glimpse into the potential of time travel. They remind us that the universe is full of mysteries waiting to be unraveled and that our understanding of it is constantly evolving. Even though these concepts are still largely theoretical, they provide a glimmer of possibility for time travel. If time travel were possible, have you ever thought about the potential implications and dangers? As we delve deeper into the mysteries of time travel, we cannot ignore the paradoxes and perils that come along with it. To begin with, let's talk about paradoxes. In the world of time travel, paradoxes are situations that defy logic or reason. A famous example of this is the grandfather paradox. This is a hypothetical scenario where someone travels back in time and kills their own grandfather before he has a chance to father their parent. This would mean that the time traveler could never have been born. But if they were never born, how could they have gone back in time to kill their grandfather? This creates a loop of events with no clear beginning or end, a classic time travel paradox. Then there is the bootstrap paradox, which involves objects or information that exist without any clear origin. Imagine a time traveler who gives a young William Shakespeare a copy of Hamlet, which the bard then copies and claims as his own. Centuries later, the time traveler finds this copied version of Hamlet, takes it back in time, and hands it to Shakespeare. So, who wrote Hamlet? This paradox defies the linear progression of cause and effect that we're used to in our day-to-day lives. Now, let's talk about the perils of time travel. One of the most significant dangers is the potential for unintended consequences. Say you travel back in time and change something seemingly insignificant, like squashing a bug. This could set off a chain of events that drastically alters the present, a concept known as the butterfly effect. The butterfly effect suggests that a small change in one state of a deterministic non-linear system can result in large differences in a later state. Essentially, the squash of a bug could potentially lead to the extinction of humanity. There's also the risk of creating a temporal loop where a time traveler gets stuck in a particular period in time, repeating the same events over and over again. Imagine being stuck in your most embarrassing moment, living it on repeat. Not a pleasant thought, is it? And let's not forget the ethical and moral dilemmas. Who gets to decide who can time travel and to when? How do we prevent misuse of this power? Could it lead to a time-traveling elite with the ability to manipulate history to their advantage? It's clear that even if time travel were possible, it could come with its own set of complex issues, while the concept of time travel is fascinating. These paradoxes and perils remind us of the importance of treading carefully as we continue to explore the mysteries of time and space. From the realms of science fiction to the frontiers of theoretical physics, time travel remains an intriguing concept. We've embarked on a fascinating journey through time, exploring the theories and paradoxes that make this topic so captivating. We began by unpacking the concept of time travel, a hypothetical ability to move between different points in time. Though it's a staple in science fiction narratives, in the real world, we've yet to find hard evidence that it's possible. But that doesn't mean we've stopped questioning and exploring. The science behind time travel led us to some intriguing discoveries. We discussed the possibility of wormholes, those hypothetical tunnels that could connect two different points in space-time. Imagine stepping through a door in your living room and emerging in the Jurassic period or the distant future. Then we touched on the theory of negative mass, a type of matter that could potentially be used to create these wormholes. However, it's important to remember that negative mass currently exists only in theory. We're still far from proving its existence in the real world or utilizing it for time travel. Yet, Even if time travel becomes possible, it's not without its potential dangers and paradoxes. We explored the idea of changing the past and the ripple effects it could have on the present and future. And let's not forget the paradoxes. The classic grandfather paradox gives us a glimpse into the mind-boggling scenarios we might encounter if we could move through time. Whether time travel will ever be more than a fascinating theory remains to be seen. But one thing is certain: it will continue to captivate our imaginations and inspire us to keep pushing the boundaries of our understanding. After all, isn't the pursuit of the unknown what drives us as a species? So let's keep questioning, keep exploring, and who knows? Maybe one day we'll find ourselves stepping through a wormhole into the unknown.